This problem is about the collision between the two objects. In this case, the collision is perfectly elastic collision. What is the elastic collision? The elastic collision is the momentum and the kinetic energy both are conserved. There is no loss in the kinetic energy. In elastic collision and in, in elastic collision, both momentum is conserved. But in the elastic collision, the kinetic energy is also conserved. In this case, we have to find it out if the two objects collides and if the collision is perfectly elastic, what is the change in kinetic energy of one object? So let's try to, uh, I'm going to explain this problem. Here, you have one mass here, this mass. I'm calling this mass the M1 mass. And this mass is moving with a velocity which is v1I. The 1 is for this object and I is the initial. I refers to initial. Okay? And the other object is the second, this is the second object, and this is moving in opposite direction. And this mass is m2, and the same way I'm calling the velocity v2I. And v1I and v2R are in opposite direction. When these two objects collide, what is the change in the kinetic energy of this system if the collision is elastic? So during the elastic collision, both momentum and the kinetic energy are conserved. So I'm just writing out the expression for the final velocity, and this is strictly for the elastic collision, is m1 minus m2 divided by m1 plus m2 v1I. And the I and the F here refers to the final velocity here. The same with 2m2 m1 plus m2 times v2I. So if you know the initial velocity of both objects, this is for the first object and this is for the second object, and if you know the mass, then you should be able to calculate what is the final velocity. Now let's plug in all the numbers here. The mass m1, what is the mass m1? The mass is 620 gram. So just need to change this number to the kilogram, which is 0.62 kilogram. The mass m2 is 320 gram. 320 gram. Again, you need to change this one to the SI system. And once you do that, you just have to divide it by 1000. You'll get 0.32 kilogram. Just plug in all the numbers here now. The mass is 0.62, 0.32. This is 0.62 plus 0.32. And this velocity is 2.1 meter per second. So this is 2.1 plus. Now the mass m2 is 2 times 0.32, and the mass of the first object is 0.62 plus 0.32. The velocity of this object is the v2 is given 3.8, and remember this velocity is moving opposite, so you have to use the negative sign here. The negative sign means it is moving opposite to the velocity v1I. So if you do not put the negative sign here, you will get a very odd answer. So you must have to put the negative 3.8. And the reason for this negative sign is because the second mass is moving opposite to the first mass. Once you plug in all the numbers, the answer you will get is negative 1.92 meter per second. This is the final velocity for the first object. You do not need to calculate the final velocity of the second, but I'm doing it anyway. If I need to find out the final velocity, which is not required, but I think I'll just do it. 2m1 plus m2 v1I plus m2 minus m1 over m1 plus m2 plus m1 times v2I. Here you have, this is v2I here, v2I. So you just need to plug in all the numbers here. You know the mass, you know the velocity, and again, this v2I would be the negative. Once you plug in, the answer you will get is 3.98 meter per second. This is the final velocity of the second object. Okay? So the last thing you need to calculate here now, what the change in the kinetic energy for the mass 1. And I'm just writing down here V1F is negative 1.12. We do not have much space here, so I might have to erase this portion here. Okay, so we need to calculate the change in the kinetic energy of the first object. Change in kinetic energy of M1. So how do you calculate this one? In order to calculate the change in kinetic energy, you need to know the final kinetic energy. Final kinetic energy negative would be initial kinetic energy. Initial kinetic energy. What is the final kinetic energy? The final kinetic energy is half m1 v1f square negative minus half m1 v1I square. We know the mass. The mass of the first object is 0.62. We just calculated this velocity here, which is 1.92. Negative 1.92 square. And this one is half. M1 is 0.62. And the initial velocity is given, which is 2.1. 2.1. Plug in all the numbers, and then the answer you will get is negative 0.22, and this is the energy, so the unit has to be joule. What does the negative sign means? The negative sign simply means the kinetic energy is lost. That means its final energy is smaller than its initial kinetic energy. So this negative sign simply means energy is lost. So this doesn't mean the total energy is lost. This only means the energy of the first object is smaller. Where does the where is the energy lost? The energy is this energy is imparted to the second object. If you calculate the change in the kinetic energy of the second object, you will get exactly the same amount. The change in kinetic energy of mass m2 would be exactly 0.22 joule, because this energy is imparted to the second object. And the one thing I need to mention here, see, is after the collision, what happens now? So after the collision, so this is before collision, and after collision, this object starts moving in this direction, and the second object starts moving again in the same direction. So once this object is approaching and once it collides, both objects starts moving in the same direction. And the velocity of this object after the collision is negative 1.92. I'm just putting the numbers here. And this one would be 3.98. This is meter per second. So after collision, both would start moving in the same direction. And for those who are a little bit more curious about knowing the physics, if you calculate the relative velocity of this object with respect to this object, it has to be the same before collision and after collision. If you look, the velocity with this object is approaching, or the relative velocity before collision, has to be exactly the same as the relative velocity, because the gap, the velocity gap after collision has to be equal to the velocity gap before collision.